In this episode, we settle into one of the most common and most painful cloud security failures, putting data somewhere convenient and then accidentally leaving it open to the world for longer than anyone realizes. What makes this topic tricky is that public exposure rarely comes from a single dramatic mistake that feels obvious in the moment. Instead, it often comes from a series of small decisions that each seem reasonable, like sharing a file for a quick test, opening a path for a partner, or turning on a feature to solve a problem fast. When those decisions happen around storage, they can quietly become durable, meaning they stick around long after the original need is gone. The goal here is to build storage access patterns that are durable in the good way, where access stays safe by default and stays safe over time. By the end, you should be able to explain what accidental public exposure looks like, why it happens so often, and what kinds of access habits prevent it without making teams feel like security is blocking progress. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The first step is getting clear on what we mean by durable storage access patterns, because the phrase is really about behavior and design choices, not about any single product or feature. Storage is where data sits when it is not actively being computed on, and in cloud environments it often takes forms that feel simple, like buckets, blobs, containers, shares, or managed file systems. Durable access patterns are the repeatable ways people and systems reach that data, including how applications read it, how users download it, how pipelines write it, and how partners or vendors retrieve it. Accidental public exposure happens when one of those patterns creates a path that does not require the right identity, the right network placement, or the right checks before data can be accessed. The word durable matters because storage permissions and sharing links tend to outlive the moment they were created, especially when nobody owns cleanup. If you remember one idea from this episode, it is that safe storage is not a one-time setting. It is a set of defaults and habits that keep working even when nobody is actively thinking about them. It helps to separate two different ideas that people often blend together: intended sharing and unintended public access. Intended sharing is when a team deliberately makes something available beyond a tight internal group, like publishing a public dataset, hosting a website asset, or distributing a software update. Unintended public access is when something becomes reachable by people who were never meant to have it, either because a permission was too broad or because a boundary was missing. The danger is that both situations can look similar at a distance, because both involve data that can be retrieved without much friction. Beginners sometimes assume that public exposure must mean someone pressed a big button that says "Make Public," but it is usually more subtle, like inheritance of permissions, default visibility settings, or convenience options that bypass identity checks. Another misconception is that public exposure only matters if the data is secret, but even non-secret data can become risky when it reveals structure, customer relationships, internal naming, or patterns attackers can use. When you think in access patterns, you stop asking "Did we make it public?" and start asking what paths exist, who can use them, and how long they last. One major cause of accidental exposure is confusing where data lives with who is allowed to see it, because in cloud systems those are independent choices. You can store data in a place that is highly available and globally reachable, and still restrict access through identity and policy, but that restriction only works if it is actually enforced. People often rely on location as if it were a lock, like assuming an internal storage name means it is internal, or assuming a private project means the data is private. In reality, access is controlled by explicit rules, and those rules can be changed by a wide set of actions, including automation, templates, or inherited settings. Another common confusion is between authentication and authorization, where authentication is proving who you are and authorization is proving you are allowed to do this specific action. Public exposure often means authentication is not required at all, or authorization is set so broadly that it might as well be public. Durable safe patterns treat identity checks and permission boundaries as the primary protection, not the assumption that nobody will find the data. A second major cause is the use of shortcut sharing methods that are designed for convenience and speed because they can bypass the normal friction that prevents mistakes. Think about the way people share a document link in everyday life, where anyone with the link can view it, and the link can be forwarded. Cloud storage systems often support similar ideas, such as anonymous access, broad read permissions, or shareable links that are not tied to a specific identity. The problem is not that these mechanisms exist, because sometimes they are necessary, but that they are easy to create and hard to track, especially when they are treated as temporary. Temporary tends to become permanent in real life, because people move on, projects finish, and nobody wants to break a workflow that seems to be working. Durable access patterns treat shortcut sharing as a controlled exception, not a default, and they include a clear expiration mindset where access must naturally end unless someone deliberately renews it. When you design the system so that safe access is easier than unsafe access, you reduce accidental exposure without needing heroic discipline. To build durable safe access, start with the idea of explicit boundaries, meaning you separate storage into zones that match the sensitivity of the data and the expected sharing model. A simple mental model is to imagine one zone for public content that is meant to be reachable by anyone, another zone for internal content used by employees and systems, and another zone for restricted content like customer data, credentials, or regulated information. The goal is not to create complexity for its own sake, but to prevent one accidental setting from turning everything into a public leak. When data of different sensitivity levels is mixed together, it becomes harder to apply the right rules consistently, and it becomes easier to justify broad access for convenience. With clear zones, you can put stronger default policies on restricted zones, such as denying anonymous access entirely, requiring identity-based access, and limiting who can change permissions. Even as a beginner, you can see the logic. If one folder holds both marketing images and database exports, someone will eventually set access for the marketing work and accidentally expose the exports too. Another durable pattern is to prefer identity-based access over location-based or link-based access whenever the data is not intentionally public. Identity-based access means each person or system has an identity, and permissions are granted to that identity or to a role that identity can assume. This matters because identity-based access is auditable and revocable, which means you can answer who accessed what, and you can remove access when the need ends. Link-based or anonymous access often lacks that control because it can be used by anyone who obtains the link, and the system may not know the real user behind it. A beginner-friendly way to think about it is the difference between lending a key to a specific neighbor versus leaving a key under the doormat. Both might solve the immediate problem, but one creates a durable security posture and the other creates a durable risk. Identity-based access also encourages least privilege because you can grant the minimum actions needed, like read but not write, or access to one dataset but not everything. Over time, those small discipline choices stop the slow growth of broad permissions that eventually become public exposure. A related pattern is to treat permission changes as high-impact events because they effectively redefine the boundary around your data. In many incidents, the moment data became exposed was not a data movement event, it was a permission event, like changing a policy, adding a group, or enabling public read. If permission changes are easy and unreviewed, mistakes will happen, and they will happen silently because nothing looks broken. Durable access patterns create friction in the right place, meaning it is easy to request access and get the right access, but it is harder to grant broad access or enable public paths without deliberate intent. This can be as simple as separating duties, where the person who needs access is not the same person who approves the broad permission change. It can also involve using templates that default to private, so people have to opt into public behavior rather than accidentally inheriting it. The key is recognizing that permission changes are not routine edits like renaming a file. They are security decisions that deserve a different level of care. It is also important to understand the difference between read exposure and write exposure, because beginners sometimes focus only on whether outsiders can download data. Public read access is dangerous because it leaks information, but public write access can be even worse because it lets attackers place content, overwrite content, or plant malicious files that others will trust. Imagine a storage location used to host application updates, images, or configuration files that get pulled into running systems. If an attacker can write to that location, they can potentially change what users and systems receive, which can turn a storage mistake into a pathway for compromise. Durable storage patterns separate who can read from who can write, and they reserve write permissions for the smallest possible set of identities. They also avoid patterns where a publicly accessible location is used as a shared drop zone for convenience, because that is exactly the kind of pattern that gets abused. Even without tool-specific details, the concept is simple. Reading is leaking, writing is tampering, and both can be triggered by overly broad access. Another teaching beat you need as a beginner is the idea of time-limited access as a security control, because time is a boundary, just like identity and network placement. When someone says they only need access for a day, a week, or for a single transfer, that should translate into access that naturally expires. Accidental exposure often happens because temporary access was granted with no built-in end, so it simply remains until someone remembers to remove it, which might be never. A durable access pattern assumes that humans forget, teams change, and priorities shift, so it builds the end into the design. You can apply this thinking to human access and system access, where human access might be for troubleshooting or review, and system access might be for a batch job or integration. If the system forces you to renew access intentionally, you create a repeated moment to confirm the access still makes sense. That renewal moment is powerful because it prevents stale permissions from quietly accumulating into a broad and risky access surface. Visibility is another pillar, because you cannot prevent accidental exposure reliably if you cannot see how storage is being accessed and how permissions are being used. Beginners sometimes assume that if a storage location is private by policy, it is safe, but policy without observation is just a hope. Durable patterns include logging and monitoring that tell you when access happens, from where, by which identity, and using what type of request. That information is useful for security detection, but it is also useful for safety checks, like noticing that a sensitive dataset is being accessed from an unexpected region or by an identity that has not been used in months. Another visibility idea is inventory, which means knowing what storage locations exist, what sensitivity they contain, and what the current access posture is. Many public exposure incidents are made worse because the organization did not even know the storage existed, especially if it was created for a short-lived project or a test. Durable patterns treat storage as an asset that must be tracked, not as a temporary scratch space that can be ignored after it works once. A subtle but important angle is how accidental exposure can happen through indirect paths, even when you think the storage itself is locked down. For example, an application might retrieve data from storage and then serve it publicly through a web endpoint, effectively turning private storage into public content. In that case, the storage control might be correct, but the access pattern through the application might be too permissive. Another indirect path is when backups, logs, or exports are stored with weaker controls than the original data, because people treat them as operational artifacts rather than as sensitive content. Those artifacts can contain the same secrets, the same personal data, or even more context than the source system. Durable access patterns extend to the entire life cycle of data, including copies and derivatives, because attackers do not care which copy is easiest to steal. The beginner takeaway is to avoid thinking only about the primary bucket or primary share, and instead think about where data is duplicated and how those duplicates are protected. When you build consistent access patterns across primary and secondary data, you reduce the chance that the weakest copy becomes the leak. It also helps to develop a simple set of red flags you can recognize quickly, because beginners need practical intuition as much as they need definitions. One red flag is any access method that works without a named identity, because anonymous access removes accountability and makes revocation hard. Another red flag is any permission granted to a very large group, especially a group that includes external identities, because that increases the chance that someone unintended has access. A third red flag is any storage location that is used by many unrelated workflows, because shared infrastructure tends to accumulate exceptions, and exceptions are where safety erodes. A fourth red flag is any storage that is created outside the normal provisioning path, like personal experiments or untracked projects, because those often miss the guardrails. None of these red flags means something is automatically wrong, but they are strong indicators that you should look closer. Durable storage access patterns exist to make those red flags rare and to make them visible when they do happen. Finally, you should connect this topic to the broader security mindset you are building for the certification, which is that reliable security comes from designing for human behavior rather than hoping humans behave perfectly. Accidental public exposure is not primarily a technical failure. It is a systems failure where defaults, incentives, and visibility did not support safe outcomes. When safe access is harder than unsafe access, people will choose unsafe access under pressure, and they will not even feel like they are making a risky decision. When safe access is the easiest option, and when broad access requires deliberate steps, you get a durable pattern that holds up during real work. When time limits are built in, stale access cannot linger forever. When visibility is strong, mistakes are caught quickly, and the blast radius is smaller. All of these ideas build toward the same outcome. Data stays available to the right people and systems, but it does not quietly drift into public exposure because of a forgotten setting or a convenience shortcut. When you zoom out, preventing accidental public exposure is about making privacy the natural resting state of storage, and then allowing carefully controlled exceptions when public sharing is truly intended. The durable part is the consistency, where access decisions are repeatable, explainable, and resilient to team turnover, project churn, and moments of urgency. If you can explain the difference between intended public content and unintended public paths, you already have a strong foundation for spotting risky designs. If you can argue for identity-based access, clear boundaries by sensitivity, and time-limited exceptions, you can prevent many of the incidents that become news stories. If you can also explain why logging, inventory, and ownership matter, you can help an organization find problems early instead of learning about them from outsiders. Most importantly, you can carry the lesson forward into other cloud topics, because the same pattern repeats everywhere. Defaults, boundaries, visibility, and durable habits are what keeps simple mistakes from turning into major exposures.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.